All right, what is up, everyone? Welcome to week 88 of building my own operating system. Good to be back after a week away, and last week was pre-recorded, but we're back at it live. Give me just a moment, as usual, to get things set up. But yeah, today it's going to be, let's see, I kind of want to work on 64-bit today. Or at least give that a try. Give me 1 second. Gotta get the mirror board going. Okay. Week 88. It's October 5th. And yeah, 64-bit. So that's sort of the general concept. And let me see if I can pull up why I want to do this. NSG 650 had a good thread. Let me see, you gonna pull this up? Yo, what's up, Windows 1.0? It looks suspiciously like cat flare. Nice to see you. Cheers. And you are not late at all. You are very early, in fact. You were one of the. Thank you for the test one. So yeah, NSG had this good thread somewhat recently, and I felt kind of inspired, and in particular, I felt a little bit called out because one of his big tips is to avoid multi-boot 2 and 32-bit. And this is exactly the setup that I'm using. And yeah, I sort of feel officially curious enough to explore this a little bit. I'm already using Limine bootloader, but I'm not using the Limine boot protocol because my OS is 32-bit. And the Limine protocol only supports 64-bit operating systems. And I actually found the reasons fairly compelling here. It is actually very impressive and convenient that Limine supports a lot of architectures, and I don't believe Grub has the same level of support somehow for that. So actually, yeah, that's pretty attractive, being able to just target a single bootloader and have it work on a variety of architectures. So anyway, I am feeling a bit inspired to check this out. So that is sort of the plan. I don't know. I mean, there's a couple of things I had in mind, so I don't know exactly if we'll get into it right immediately, but that's sort of the general idea. And so maybe without further ado, let's start to ease into it. But yeah. Gonna send a tweet in the chat. Yes, again. SG. Well, let's see if I can send links in the chat. That has been a problem. But maybe that's just for other people. Maybe I'm allowed to send links in my own chat. So yeah, I'll be curious what you think, Catflare, about this, because you also have some experience and have been in the community for quite some time. But overall, yeah, I thought it was a good thread. Yep. Okay, so let's see what I was doing. I have a somewhat messy working tree right now. I was playing around with C++ ranges, and I actually did get these working for the OS and was able to use some of the ranges functionality. So I don't know. I'm not going to worry too much about the Git stuff today. Try using ranges. Yeah, just as a recap, I haven't been, just in the last commits, I was just refactoring a little bit. My opinions are the same as NSG's, to be honest. Okay. Yeah, sort of figured as much. One win that I had recently is I've been migrating away from this file called types.h. And so that was a file in JOS that created a lot of these basic like integer types in C and a Boolean type and uint pointer t and like all sorts of stuff. And now that I have an actual set of standard library headers, I'm able to use those for a lot of things instead of these hand-defined things. So, all right, chat's popping off today. What's up, Zardis? What's up, Tugra and Afnan? Yo, what's up, everyone? Zardis, am I using is that a Wacom tablet? No, this is not sure what you're looking at. This is a keyboard. I have an Apple mouse here, and then this is my Ableton Move. And Afnan, thank you. Road to 10K. Slow and steady. Maybe, yeah. Maybe someday. Maybe someday soon. We'll see. The algorithms have been kind of crazy on the internet recently. I've experienced just a lot of volatility with views and stuff like this, but thank you. Yeah, maybe we'll get there. Okay. So anyway, big win was I was able to kind of remove a lot of types.h and replace it with these standard headers. And that was pretty nice. And then lastly, I had to patch ETL a little bit to get it working for std ranges. Okay, but enough of all that. Let's get into today's topic, which ostensibly is 64-bit. And the specific goal would be to sort of get, I don't know, a basic boot working in 64-bit mode. Probably, I mean, we are currently using Limine bootloader. But there's actually a lot of open questions I have about how to actually do this. Because and it actually exposes some knowledge gaps that I have. Yo, what's up, man? What's up, Syed? Thanks for joining. So this exposes a lot of knowledge gaps that I have, and it'll be a good refresher for the boot process. Because currently we are getting execution here from Limine, and it puts us into this entry.s file, which is written in a small amount of assembly and then it just does some basic bootstrapping of the virtual memory and enables paging, and then jumps into C or C++. So question, I have a lot of questions. Do I need to rewrite entry.s in 64-bit? I mean, there's also all these really nice templates, Limine, GitHub. Probably following one of these templates. Okay, I think the templates got moved to Codeberg. So yeah. And so this is probably, what's up NSG? We were just talking about you. You can skip the paging part. So it's possible to make kmain the entry point directly. Okay. I'm going to screenshot that tip. Nice. So if I understand correctly, we're going to use Limine boot protocol, and then yeah, I just need to learn about what, I think I just need to read a bit more about this. But NSG is saying we can, if we're using 64-bit, Limine will already take care of enabling paging in some kind of way. And so basically you make kmain the entry point directly. Okay, let's try this. I will just make Limine, I call it Limine 64-bit. Probably it would be good to have these templates. Maybe I'll get the template just for reference. Maybe I'll get the CXX template because I'm using C++. Okay. Do I already? No, I don't. Yeah, clone. Okay. P, let's, can I not, interesting. In Limine on entry point, you have paging all set up. Higher half memory is also set up. You just gotta align the stack and jump to kernel main. I am so lucky to have two Limine experts in the chat right now. So I got the template to reference. Probably also just having the protocol here. I'm just trying to find where this stuff is actually documented, but it's probably here. So I think I'll just take a moment just to read through this a little bit. Or maybe let's just browse through the template. Maybe let's just see what's here. So what is in this template? Limine.conf. Don't worry, Afnan, I don't really know what I'm doing either. Okay, but we can, we can just start out with reading how this template works, and then hopefully I can get a sense of what changes I need to make. So nice, easy steps. So obviously they're using the protocol Limine. I will need to change my limine.conf to say this. And then, okay, so there's like, and then what, so what's the source? Okay, so this is like a really compact, wow, kernel with just like all, okay. So I am going to start copy pasting stuff, I think. Okay, I guess I will start copy pasting a few things. Okay, there's an inline names. There's like 3 inline namespaces, which is kind of interesting. And okay, you know what I'm going to do? I'm actually going to revert this commit. It just creates a little bit too much noise in this file. Okay. So yeah, Saya, the series looks fascinating, but I'm curious to know how this helped me later on in the AI era. Yeah, that's a deep question. My super short answer is I'm betting on, I'm betting that deep expertise in how systems work will always be valuable. And that's what we're doing here. We are developing deep expertise. Yo, what's up, Dash? Yo, cheers, bro, Afnan, thank you. I got a good barber. Okay, so, limine.h. Let's get a copy of limine.h. There is no limine.h. Is this limine.h? I think so. I'm just going to go ahead. Ooh, whoa. Holy, why? Hello? Somehow I activated the mic. Okay. So okay, so let's copy limine.h into kern, just for starters. So now we got our limine.h, so that should be accessible now if we, okay, cool. So I don't think I want the frame buffer request actually, so I'm just going to not. I'm at my, because all I want to do is just get loaded and then be able to write to the serial console. And so I don't need anything fancy like a frame buffer. So let's see. Okay, I'm just going to keep track of what is being done. So copy in the Limine code into kmain at limine.h. We need linker stuff. Just trying to see, this is, so I expect we'll need to do some linker stuff and adjust limine.conf. Yo, what's up, Digitalized? Got a good crew in the chat today. Digitalized, I'm playing around with porting to 64-bit using Limine bootloader and actually using the Limine boot protocol. And I'm being helped out by some experts in the chat. Okay, so this is a pretty basic file, and technically, yeah, oh no, no more 32-bit. Yeah, I don't know. For reference, NSG had this thread that I was pretty, that I found pretty compelling. And I was actually always kind of curious what it would be like to go with 64-bit. And it does make some things easier. Panic. Okay. So, yeah. This isn't necessarily meaning we're gonna go with 64-bit full on for the future, but I'm at least curious to see what it would look like and see if I can speed run this right now. So, all right, let's talk linking. So what does this get? Depths. All right, where 64. What? I feel like something. Okay. I just wanted to know where this file is mentioned, though. Why does it appear like it is never being referenced, even though there's a file here? Oh, I think here is where that happens. Okay. LD flags. So I am curious what the LD flags look like. And then there's also this linker script. Yo, what's up, Ismail? Nice to see you. Yeah, we got a good crew in the chat today. All right, first step, let's look up, okay, linker flags. So let me check out what linker flags I'm using. Okay, so this is gonna change. So Ismail, for context, we're playing around with 64-bit mode today. So okay. Something seems whack though. What? Why? Something is whack. It sort of seems like base LD flags is not used, which doesn't make any sense. So clearly, kind of funny that the build actually did work just now, even though I have been kind of messing with stuff. So am I like, am I blind? Why? Oh. Yeah, something. Files? Oh, it's because of this? No, oh, it's because of this. Okay. Whew. Sheesh, okay. So yes, these are included over here. And there are some more, there's one more linker flag just for this. We'll get back to here. So LD flags pretty much just has the one thing, I think. And then, or actually no, then there are some more here. Kind of interesting. Okay, so now let's take a look. So I don't know if I really need all of these, but I'm just going to add them. Static? No, what am I doing? And then some specific linker script. Just curious. So we are already passing dash static in the C flag. So yeah, I don't know if we need this here, but okay. And lastly, the linker script. So let's check this out. You know what, maybe the C template is also a little bit simpler. Clone. Because I'm not, I mean, there's like a lot of this noise in there about constructors and whatnot, and I'm not really making use of any of that. So yeah, okay. So, and this is what NSG was talking about with the entry in the k-main. So let's just kind of like duplicate a bit of this. I will minimize this. Okay. So output format. No, it does not work. Okay. I have no idea why you need to say ELF32 i386 3 times. But okay, output. There's a no reference to output arch. Entry k-main. Okay, now this is where things are going to get interesting because so here's where we define the load address of where we expect the kernel to be loaded. And and this is going to be pretty different. Okay, one thing at a time. So let's, I don't know, let's do this maybe. Apparently there is this thing apparently it uses section names somehow, and I really don't understand very much about that, but okay. And then there's just some fairly normal stuff about the text. Here we are specifying the physical load address, and I do not necessarily see that here. Next page. Where does that constant come from? I do not know. Instead of passing the info via the argument in k-main, Limine just loads the values in while loading the kernel. Interesting. Yeah, I think I saw something about that. That's a pretty cool feature. Okay, so I don't really know. I guess I'll just leave this here. And it is kind of interesting that there is no alignment. So yeah, maybe time just add some alignment. RO data. Okay, this is something that's not critical, probably. Regular data. Okay, then BSS comes at the end. Okay, so my questions are like the physical load address, but otherwise, Okay. And then what do we do about this, though? I mean, maybe let's just straight up copy it. This, why did that not work? Okay. And then there's this thing. Since Limine is follow the kernel base. Interesting. NSG, do you know anything about this, the physical load address thing? For whatever reason, my kernel was specifying that, and it still will be using that, and I'm not sure how Limine will handle that. I don't know, like, yeah. I mean, Limine surely is just going to interpret the load segments, and it's going to load me here. Limine doesn't care about the physical. Interesting. But there needs to be some physical load address, though, right? Like the binary is going to have something in it, right? Okay, maybe that is something that we will learn more about in the future. Okay, so I think I mostly have this linker script ported. True passion. Why C++ and not Rust? Simple answer, I just don't know Rust. And now is not really a great moment to learn it. But I would love to learn it. Okay. Anything else interesting? Maybe, I don't know. Limine just loads it wherever it is available. So that means Limine must ignore the physical address field in the load segment and just like not respect it, basically, if that's true. Which I don't know, which would be pretty interesting. Okay, and then, I mean, we are already sort of there. Let's just, I mean, this thing like built last time. Maybe I will completely clean things out. Okay. Seja. What happened here? Blah is incompatible. Okay, something. It's probably worth seeing the. So we got this error is happening with linking. Oh, it's this M32 probably. And here's the part where I probably need to exclude the build directory and third party. Good call. So what do I do? Do I need to M64? try it. Okay. Nice. So now, interesting. Okay, so a couple problems come up. So we're getting some compile errors in a few places. So now it's trying to compile entry.s in 64-bit mode. That's remove the emp and set the target to in the compiler flags. I mean, these are the I mean, I've never seen M64 in my life, so I don't know how legit that is. Set the target to x86 in the compiler flags. How? What if I just? I mean, you know what, I'm gonna put this back. I mean, this is like, this is weird, but it was actually working, I think. So now I just need to not include, if I am getting this right. Oh shit, yeah, I see elfpc, or I see what you're saying. True. Kern, wait, no, it's toolchain. Okay, this is all in toolchain that's seeming. So let's try this. So what? The question is, what do I put here though? I'm gonna guess. I'm just gonna make a big guess that this is the right string. That's interesting. That actually completely worked. But yes, also I removed. So if I add these back in, I think it will fail again with the same errors. But actually, so if I'm understanding correctly, we just don't need any more entry assembly if you're using Limine protocol. And you also don't need entry page tables. Apparently, Limine sets up some kind of entry page tables for you already. So this is interesting. And I think it's time for a commit. So at least some kind of whip commit. I don't know. We have a bunch of changes to the k-main. Interesting. So yeah, okay, so 64-bit requires paging to be enabled. And so if the goal is for Limine to hand over execution to you in 64-bit mode, that means it must have already enabled some kind of paging with some kind of page tables. I'll be interested in how it does that, like what kinds of page tables it constructs. But yeah, that is actually different because with 32-bit mode, the Limine drops you off and you're in 32-bit mode without paging. And then that's like the whole point of these two files, is to enable like a basic paging and then jump into C. We don't need that at all anymore. So, okay, lib basic Limine 64-bits. Okay, so now we can finally come back here. And do this, and the only other thing I can think of to do is look at the QEMU flags. And I am still planning to use BIOS booting for now. For the sole reason that it's just kind of annoying to pass this like OVMF command line argument to QEMU. So I just don't want to do that. And so if we're using BIOS booting, the command line flags seem somewhat simple. Then pass. Okay. So where is the QEMU thing actually? I think that's in the top for some reason. No. Once again, am I blind right now? Tool, okay. So, oh. Okay, this is interesting. So, I have been using my own build of QEMU for quite some time, which is only, okay, 32-bit, so I'm gonna swap out and come and use the homebrew one again. And then NSG is saying to pass the -MQ35. What does that do? Interesting. So we're upgrading chipsets. A more modern x86 platform compared to the default PC. Yeah, let's do it. Sure. Okay, so CD-ROM, it's the machine. Emily's the machine with the, okay, cool. So I'm already passing the CD-ROM. And then there's boot space D. What does boot D do in QEMU flags? Boot from the first virtual CD-ROM drive. Maybe we'll see how necessary that is, but I'll just add it. And then QEMU flags. Let's check out default QEMU M. I am going to assume that the only QEMU flag does M2G do. I'm gonna guess that's the amount of physical RAM to give to the guest. And we're going all in with 2 gigabytes of RAM, YOLO. For reference, I've been working with, I believe it's just the default, which is 256 megabytes. And actually, maybe I would just be curious if I even need this though. I'm just curious if we can just still boot with 256 megabytes of RAM. Okay, so, and with all of that done, let's run it. Kikimu. Well, what actually is going to happen? So I will actually just put a panic immediately here. Also there's no argument anymore. So if we can just get to here, then if we can even just get to here, I would be thrilled. So let's try that. Oh, okay, but okay, now things don't compile because there's no multi-boot anymore, so all that goes away. Okay. First run of the day. Lower half P headers are not allowed. And I think that's a good time to take our first break of the day, which I realized I never did. So let's go ahead and do that. Be right back. All right, just check in the Twitch chat. I see some messages. What's up, Chandu? So someone put some emojis in there. Nice. Oh, I just realized my my stream chat widget has been off the entire time. Bummer. All right, time for a test 2. Ah, okay, bummer, okay. Now it's active again. Okay, whatever. So lower half P headers are not allowed. And we can see us. Okay. What does that mean? What does lower half P headers mean? So you need more math when building? I would say not really. I would say for the most part, OS Dev is not the most crazy mathy type of programming that one could do. So maybe time to do this. Does that help? That Did not help. Just curious. Read elf. Read elf. 664? Dang, do I even have a read elf anymore? Where? What? I'm just gonna try. I'm just gonna try the 32-bit one on this binary. Look at this. Seems wrong. Gotta say, something seems, but all right, how do I know, like, for real? No, syntax highlighting. Elf. Yeah, it looks wrong. But is it just... I'm like low-key searching. Search. I mean, obviously there should be... it's homebrew. Like, I have LLVM installed, like, what? Oh, is it just not in my path or something? Okay, well, I will just, how do I temporarily add something to my path? I'm gonna ask how to really add something to my path in fish shell. This is something I just don't do very often. Aha, okay. History. Sorry. Okay, so we're just gonna go ahead and just add this to the path. Did not do that. Okay, read elf, good. So now I'm just gonna try that again, just in case. But yeah, no, this is great. This is messed up. So how do we know it's messed up? We know that it's messed up because both the virtual address field and the physical address field are 0. This virtual address thing should be that this high number, right? And just out of curiosity, what if I reverted this commit? Oh, dang. And rebuilt, and then we look at this one more time. What? Okay, this is, so there, I was slightly expecting to see something here. Is this file even like working? like, do we even get a build error? What? Oops. It's okay. So that failed. So, but apparently inserting this is valid linker script syntax or something. Okay, so the file is in fact being interpreted, which is a good sign. Okay. Yeah, no, probably. I think we need to be looking at the actual command lines here. So pretty much just this one. And you can just see that, okay, we just passed some of these flags, and then we are passing just some object files like kmain and some other stuff. I mean, if I want to make this even more minimal, which I probably do, I probably just want to get rid of like these two things also. Okay, slightly simpler. So there's really not too much here. And yeah, so like what? Well, you know what? I mean, I am using potentially a different linker. I don't think they're using LLVM here. Or CC is Clang. No, they passed M64. Okay, but linker time. So I'm like, what is toolchain prefix? Okay. So LLVM is supported. Okay, so LLD is supported. And that's what I'm using. Just rip from their example and see. Yeah, that is, it's a solid idea. All right, let's just go for it. I'm just going to for Limine. Okay. So let's just right. All right. Straight up ripped the and that worked. That worked somehow. So thank you for the suggestion. That was a good idea. We got the panic, and so clearly there was some difference between the two linker scripts. I'm happy to use whatever linker script works. As data. Just curious. Does it use the functions? What's it called? Function sections? Function sections, almost certainly, because the Limine developers are pretty elite. I just remember it took me, when I enabled functions sections, it actually took quite a bit of fiddling with some of these things to keep it working. But it seems that they support that too. So I guess actually I copy and pasted the C template, so maybe I actually want to get the C++ template going. Which is maybe kind of similar, except it has a bit more C++ support. Obviously, for global constructors or something like this. So let's just see if that works. That does work. Witchcraft to me, yeah, kind of to me too. Yeah, linker scripts are crazy. And especially this stuff. But okay, maybe we just take a quick moment to check in. Import Limine linker script. It's working. Okay. Well, okay, that's cool. So I don't really understand what's going on because I've just been copy and pasting code the whole time. But I guess that's sort of what I want to do now, is actually have a better understanding, for example, of like these things. Okay, the frame buffer request was in there. So just to check. Okay, so actually, I wonder if this will link still because, well, this is actually kind of interesting. So formerly I was doing my own BSS clearing. That's a remnant of using the old custom bootloader that Joss had, which did not do that for you. And I actually think that this code has been not needed for some time because I sort of think Limine does this for you. Maybe NSG, you just know this, but I would kind of expect Limine to clear the BSS for you. So that would mean I could get rid of this code. But what is actually interesting to me is that there wasn't a linker error. Okay, there we go. Wait, so what? Is that really true? So the panic is up here and it compiles. Interesting. And then I move the panic down here and then it no longer compiles because it actually starts needing to reference these symbols. So that means that the compiler must have analyzed the code and observed that there's an infinite loop here and just like did not even try to compile the rest of the code after it. Which is kind of cool, I guess. So now I don't need to clear the BSS. So, and the only reason is because I was wondering how this even compiled, because with this big linker script change, I got rid of the BSS and end symbols. And so formerly those were things that were like declared here at specific points using the provide directive. So yeah, okay, that's great. So now let's follow NSG's suggestion and try to access the command line arguments. This will be a good exercise at using something from the Limine protocol and hopefully seeing how easy it is compared to multi-boot. But we'll do that after the break, so be right back. So yo, what's up, vpool? Nice to see you. Yeah, so if we get this working, this will be a good example of how things are easier with Limine, because apparently you don't need to parse data or whatever, it just directly like initializes your memory for you or something. So how do we do this? All right, thanks for joining, Seja. Have a nice day and see you another time. So I'm just going to copy and paste, and apparently we need some request, and it's going to be the executable command line, unless, what is this thing down here? Is equivalent to the command line value. Executable file. Okay, whatever. So back up here, so we are going to, and the request is, so it's not a frame buffer, it's a command line request. And we have an ID, revision, and so, wait. So this is a struct. And we are, okay, it's like kind of obscured here, but we are declaring a global object, I believe. And maybe this is also why, actually, okay. I was going to say maybe this is also why they add all this like init array global constructors stuff. But actually, I don't even have that code yet, and it hasn't been necessary, even with these objects. But that's probably just because these objects are extremely simple. What is this? Limine no pointers. Interesting. All right. Okay, but basically it's like this struct, and we are declaring an instance of this struct globally, and we are initializing some of these fields. And so, for example, it's going to be Limine command, Limine executable command line request. Interesting. And then revision number. What do you put as the revision number? Zero. Which is I'm actually kind of curious to learn more about that, because that's a big part of the Limine protocol, is this like idea of revisions. There's like the base revision. Okay, here's how you use these features. Request and a response. Okay, every request has an ID, and then the revision. It starts at 0 and is bumped up whenever new members or functionality are added. And interesting. And then this is filled in at load time. Yeah, I agree, Ismail. These docs are quite comprehensive, so that's a big plus. That's another advantage over Grub. The Grub docs were not really that good. Okay. Back here. So we're gonna use revision 0. And then we have a pointer to the response. Okay. And we initialize this as null pointer. And then later, when Limine does the loading, it's going to actually write the response in here, I guess. So let's just take a quick look at close this over here. So here is an example of how you use this stuff. You basically have you just take the request object, and then you call dot response, and then you can use the response. So let's do that. We're going to, let's say I wanted to, I'm just gonna panic here. Actually, just quickly test that works. That worked. Okay, cool. So let's just try to log command line. And it's going to be, oh, the AI already kind of got it. So response is, again, this thing. And the response struct is this struct. And it just has this command line char. And in, ooh, but my auto formatter formatted this file accidentally. Okay. And then if we go to limine.conf, we can see that I have my, I did set a command line. It's like this random command line. It's actually compatible with the format that Frig accepts. So as a baby step, let's just observe this. Okay. So kernel command line, my int, my bool, my int, blah, 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 blah. So that is totally working. And then let's try actually parsing it. And it's going to be basically the same thing, except instead of this, it's going to be this. Right. Except, wait, so. But this does not match. So wait a sec, my bool, so my bool args, int 0 and my string view, my stir view, so basically I have these arguments that I want to be able to pass to my kernel, and I'm making a structure that's going to hold them. So they're going to get parsed into this structure. And then I just come down here and I do stuff like my bool. Then I have some of these options. So it's my int, and then my stir, and then as string view. So as string, yeah, okay, args. Okay. Cool. Why? Oh wait, but it's like store int or something like that. Parse. Store. Wait, what? Let me, here are the Frig tests that kind of show you how to use it as a number. That's what it is. NSG. Yeah, NSG, interesting that Frig offers this. I just mainly parse these. Well, I don't really feel like writing an argument parser. That's probably the least interesting part of OS development that I could think of. So I am very happy to make use of theirs. So let's just check if this compiles, and it does. So now I can do stuff like, got my, oh, check that out. Got my bool, my int, my stir, and we're just gonna pass all of these in there. And that, I might need, my panic is still here. So I'll just remove the panic. And check that out. Got my bool equals true, my int 42, my str equals I am a string. Reached end of kernel. Okay, nice. Yeah, that's pretty neat. Frig is still working. Frig is comfy. And this comment is actually wrong. There was no frig bug. It was my mistake. Finally 64-bit. Yeah, thanks a lot to you, NSG, and Catflare, and everyone for helping me kind of get through this. Yeah, this is pretty nice. So yeah, I don't need the frame buffer request, so I'm just gonna not use that. All right, NSG, what's your favorite Limine request? Let's just check out what requests we can get. Is there like a list of requests somewhere? Actually, this is interesting. So, machine state at entry. So far, I have not needed to know about any of this, which is kind of interesting because I'm just directly entering into kmain. This is actually very interesting. So there's a lot of stuff that JAWS had to do that is no longer necessary that Limine takes care of us. And so so entry asm is one thing that Limine takes care of us. Boot stack is also another. Boot stack is one thing. So if we go to the JAWS code, we can see that actually we allocated our own stack area for use when we jumped into C code. And we controlled how big that stack is. And if you want to control the stack size, you can submit a stack size request to Limine. That is interesting. But yeah, Limine takes care of setting up a stack for you. Paging is enabled. Use a stack request for getting a stack since the stack currently resides in reclaimable memory. Huh. So you're saying it's maybe risky or something to use bootloader reclaimable memory. But the stack, what is the stack request? The stack size request seems to just adjust the size of the stack, but it seems like, if I understand this correctly, it's still in bootloader reclaimable memory. So stack size feature. So with the stack size, you can pass in a stack size that you want. What about for here? Then here's that legendary multiprocessor feature, which somehow magically enables the processors, enables the different cores. That's pretty useful. Okay. So, but I'll take a note. So stack size might be interesting. Interesting address to get loaded into. Yeah, there's a lot of details here. I still don't really understand this stuff. Limine request section, entry memory layout. Protocol mandates executables to load themselves at or above. Interesting, so you don't have a choice. You need to at least be over here. And what, like, is this like the top quarter of the 64-bit address space? I think so. Lower half are not supported. Will be loaded and mapped as supervisor at the requested virtual memory address. Okay. No specific physical memory placement is guaranteed. So that is the interesting thing. And that's the thing that we were talking about earlier with NSG. Yeah, now that things are working, let's do another look at the readelf. Okay, here's an actually functional set of program headers. And they just kind of start at this address and then they go up in page increments. And what is also funny. So for some reason, the physical address fields also have these ridiculously high numbers, which, yeah, so that just means that they're being ignored probably. Now here's the part where we could go back over here and test that one more time. So we had this text thing and where was it? No, what? Ah, here. Oh, but it's time for the 20 seconds to be right back. So now what happens if I put this back in? This was the physical, something to do with the physical memory load address. And if we build the kernel and look at the readelf, now check it out. Now this kind of anchors things. This is more what I would actually expect to see from the readelf of a kernel. The point of the phys field is so a bootloader can know where in physical memory to put things. And the interesting part is that it seems like Limine just chooses its own. Yeah, Limine just totally ignores the physical address fields of the load segments, which is perhaps a bit opinionated, but in practice, I don't know if there's no concrete problems I can see with that. But usually I would kind of expect loaders of ELF binaries to respect the program headers basically. but it seems like Limine has some strong opinions about how it wants to load things, and so it just ignores the phys_adder fields and chooses its own suitable place for your binary to go. You're guaranteed that it's physically contiguous. And if you want to actually look up the physical load address, you can use the executable address feature. Let's try doing that. So what's up, BW001 in Twitch? So let's just have another, hey Shia, will these lives be available on your channel? Yes, all of the lives stay available on my YouTube channel. So let's get the Limine executable, no, what's it called? Address? Kernel. Is it called the kernel address request? Limine executable. Ah, okay. Executable. Ah, wait a sec, what? It has been renamed. Or has it? Wait, what? And wait, are the docs out of date or something? We might not just... Oh, greater than 2. Okay, so this thing got renamed. So greater than 2 is the more modern one. So how do I probably, wait. So I'm gonna want to set this somewhere in my what's up, Sham? All right, cool, got it. Oh man, the old course command. So that's a bit out of date now. We're no longer following the MIT course. So yeah, that's not really correct anymore. Usually it should be set before let's see. Yeah, I was just hoping to put it here in my compiler flags. Oh wait, how do you do this again with the -d thing? Can you? No. All right, the basic way is to do this, right? So, or I don't know what version I am, but I'll call it 2. How do I find out my version? So I have some version of Limine there as the bootloader, and I'm coding my OS against some revision. I think I don't understand this well enough. Zero through 2 are deprecated. blah, blah, blah. Okay. But wait a sec, base revision. Okay, no, I'm 3, apparently. So what does this do? So I should say 3 here. But we can see this thing, executable adder. Okay, we can see this thing change though, depending on this, which is kind of cool. Okay, thank you, Sensei. So back over here, so let's just fill in the request and full address, and there's no data you pass. Line executable address request. So now the response gives you some numbers. Physical base, virtual base. Let's try this out. Let's do it right here. Phys base. Vert. All right. Phys physical base. And maybe I want these as hex. Probably. Okay, interesting. So yeah, that matches what we're expecting. Well, I don't know about the phys base, but the vert base is that 3 quarters number. And then this, I don't know. This is like just some. So we were formerly loading at 100,000 hex, which is, I don't know, like the first megabyte or something of memory. It's now, we are significantly higher than that in physical memory. Cool. Nice. So alongside the loaded executable, the bootloader will set up memory mappings as such. And so these are these entry page tables. BW0 asks, what are we doing today? We are working on setting up my OS to use the Limine boot protocol with Limine bootloader in 64-bit mode, which is pretty new for me. Okay, base physical address. Wait, what? Base. So it maps low memory. Wait, base revision 0 only? Don't. HHDM. Start. Okay, I find this a little bit confusing. For 0, the above. Okay, but we're at 3. For basically the only memory mappings mapped to the HHDM are usable, bootloader, reclaimable, executable modules, and frame buffer. The unconditional direct map of the first 4 GB is dropped, and only memory map regions. The bootloader page tables are in bootloader reclaimable memory. And their specific layout. Okay. And then you can do KSLR or whatever. Okay. This is interesting, but to be honest, I really don't understand what the memory layout really is. The above 4 GB identity. So this was formerly some kind of identity map of low memory. And HHDM start, that is that like crazy number, right? Like the it's like that 3/4 of the way through the address space number or whatever it is. Right, okay, so it maps physical memory to the HHDM thing. And the higher half direct map, and so that is interesting. I think my question is, what is the difference between the higher half direct map and the virtual load at the virtual base? Let me just try to get it. HHDM request, okay. Ah, okay. Right, so there's this distinction between where the kernel is loaded and then where the physical memory map is. Oh, interesting. I see. In JOS, these were kind of basically the same thing because the kernel was always loaded super close to the, I mean, it was loaded at the 1 MB mark. And then just like the first 256 megabytes of physical memory was direct mapped into high memory. But okay, let's just do this. So it's gonna be the Limine HHDM request. HDM request, and HHDM request. And then now HHDM, HDM, oops, okay. Offset. The virtual address offset of the beginning of the offset from where? From 0, maybe? Oh, okay. So you were not joking about this, like, so this, so this is what, like the top 1/8 of the address space or something like that? Interesting. I think I need to let this soak in a little bit. So, okay, so I understand that we have a few concepts here. We have the kernel being loaded somewhere. The physical address is kind of arbitrary and chosen by Limine. The virtual address is specified in the linker script, and there's also this mandate in the spec as to where it needs to be. And we are currently following the template, which puts it at the lowest possible address that is spec'd. And then there's this HHDM, higher half direct map thing, which are some mappings that exist. And I think just what's confusing is that, so this thing does not apply. This is revision 0 only, which I'm not using. And so for my purposes with revision 3, there are several regions mapped to the HHDM. And do I need to like look this up somehow? Like how do I, is there some request? Or maybe it's in the memory map. Oh, okay, so then there's this memory map feature. And that's where you can maybe find out more information about how the HHDM is actually laid out, potentially. For example, is all these entries with a base, a length, and a type. And then there's like a linked list, or I don't know, something. Entry points. What's up, DJ Molly boy? It's like a Dell. It's not that special. It's like a Dell monitor. Yeah. When you're accessing physical address, add the offset. Add this offset, the HDM, to access it. Is that okay? Right. I'm gonna kill the palm tree in the last couple of minutes of the stream, so Right, I think I understand what you're saying about how to access a physical address, you just add this offset to access it. And I'm just wondering where that's documented. Like, is that what this is trying to say? Because I sort of... Okay, I guess that's what this is trying to say. Base physical address 0 gets mapped to HHDM start. Right. Mm-hmm. And additional depending on. But okay, wait a sec. So what is this trying to say? So I understand that this is saying that, okay, physical address 0 gets mapped to HHDM start, which is this number, the high 8th of memory. And then 4 gigabytes, but what is this trying to say? 4 gigabytes and additional memory map regions depending on base revision. So does the 4 gigabyte here mean that 4 gigabytes of physical memory is mapped? But if you have more, then that's not mapped? Like, how much physical memory is mapped? Or maybe that's what it says here. So for the above, for base revision 3, the only memory map regions mapped to the HHDM. But okay, and so I understand that there at the HHDM start is going to just be a linear mapping of some amount of physical memory. And I'm not totally sure how much it is, but I feel like this is trying to say it's at 4 gigabytes. But then there's other mappings that are going to be in this region. And then you need to, but then you need to find out where they are. And I suppose that's what the memory map feature is for. So, all right, cool. All right, nice. I think that's going to be it for today. But I feel like this is a really good progress, mostly thanks to all the help I was getting. But officially, the kernel is booting on 64-bit using the Limine boot protocol with C++, although that wasn't really that much of the focus. Okay, and then next time, I guess we'll just keep going with this. I don't mind being on 64-bit at all, and Limine is providing quite a lot of nice features, and it is masking some stuff that I would be interested to learn more about. But I'm happy to proceed with this and just go full 64-bit. So, all right, that's going to be it for today's stream, y'all. I will just post the Discord link. Feel free to join the Discord if you feel like it. And I hope you have a great week. and I'll see you next week, and we'll do a bit more hacking on this. All right, see you later. Peace.